I'm going to be honest with you. This, at first, is going to be very, very easy, and you're going to be like, oh, yeah, easy. Of course. This is going to be, at the end, it's going to be somewhat difficult because you have to slow down and look at it and really concentrate on it. It's something that I know that you know how to do and I know you can do. However, you are going to have to slow down and take your time. An inequality says that two quantities either are not equal or may not be equal. An inequality uses one of the following symbols. You guys have all seen these symbols before. The first one, what does the first symbol mean? Jonathan, less than. Fewer than or below. What's the next one? The next one is greater than. Okay? What is the next one, though? That one, that little symbol with a little line underneath it. We talked about it.
Less than or equal.
That means less than or equal to. Okay? So it's a less than symbol with half an equal sign on it. It's less than or equal to. And what that means is like if I said this, if I made this statement, there were less than or equal to 15 sixth graders on the bus. That means that there was either, there could have been as many, there could have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 15 sixth graders on the bus. There could not have been 16 because then it says less than or equal to 15. It could have been exactly 15. And the next symbol, obviously, then must be what? Greater than or equal to. Same thing. So, what I'm going to ask you guys to do, one of the things you're going to have to do is you have to write an inequality for each situation. And the way that you do it is you put your words first. So your words are going to be number of people. Then you're going to have some sort of symbol, and then you're going to have 15 because it says 15. Just wait with your whiteboards. Just pay attention to what I'm doing first. There are at least 15 people in the waiting room. Now, think about this for a second. Could there be 15? So my symbol is going to have to be either less than or equal to or greater than or equal to. So we're going to have the little line on the bottom. The next thing we need to go, okay, it says there are at least 15 people in the waiting room. So are there going to be more than 15 people in the waiting room or less than 15 people in the waiting room? There's going to be less than 15 people? Because there are at least 15. To me, that says there's going to be more than 15 people in the waiting room, which means it's going to be greater than. The number of people is greater than or equal to 15. Again, I told you, this is kind of simple, but you have to really slow down and think about it. Because you go, there are at least 15. Does that mean there could be 16? Yeah. Does that mean there could be 17? Yeah. It means that that number has to be more than 15. It could be exactly 15. So on your whiteboards, I want you to try the next one. Remember that you need to set it up by saying your words first, number of gallons. Then we have to have our symbol and then our number. Number of gallons is less than or equal to 10. Try the next one. Oh, wait, there isn't the next one. It's okay. Oh, I know what I did. It's okay. I'm going to erase this. There's another one. Try that one. There is at least 10 yards of fabric left. So we got amount of fabric, or I'll just put fabric for now. Amount. There we go. Okay. Also, an inequality that contains a variable is an algebraic inequality. A value of the variable that makes the inequality true is a solution of the inequality. Okay, a lot of words. Let's look at it. You're going to have problems that look like this. It says our original problem is over here on the end. A is greater than 5. So the way that you solve it is you have to draw a number line, and then you have to basically highlight everything that makes that statement true. Anything that is greater than 5. And on a number line, anything that's greater than 5 is going to be going to the right. Anything that's more than 5 is that way. Now notice, this one does not include 5. That's why it's just a circle around 5. If I was to have a little line underneath that, then my circle wouldn't be a circle, it would be a dot. And we would include 5. That little dot tells us we include 5. The circle tells us we do not include that number. Okay? And so then we have another problem here. B is less than or equal to 3. Well, we have to include 3, so we draw a dot at 3, and then we decide the alligator is going to eat everything that way. Well, basically that way. No. Everything less than 3 goes to the left, and we highlight it that way. So on your whiteboards, let's try this one. So the first thing you want to do is you want to draw yourself a number line. I'm going to put 0, 1, 2, 3, 4, -1, -2, 3. Once you've got yourself a number line, then you have to look at 3. Am I going to include 3, or am I going to, is 3 included in this or not included? Is not included. So does that mean that I draw a circle or a solid dot? If it's not included. If it's not included, it's a circle. So I draw a circle around 3. And we look at it this way. We go n is less than 3. So I want everything, I highlight everything that's less than 3. So basically I just do this, including the arrow. What I want you to do, don't get too busy coloring all this stuff because you're going to burn up my markers. But try the next one, and then hold your whiteboards up and show me. Because if you look at this one, first of all, you have to decide. You look at -4. Are we including -4 or are we not? And this one is included because it's less than or equal to. So we just draw a dot at 4. And then we have to decide. The value of A is basically anything that's more than -4. Okay, so anything that's more than -4 is going to be this way. And that's our solution. Go ahead. Some of you struggled with this one because you looked at it and you go, okay, 2. Well, we're going to include 2. So you know to put a dot there. But you have to look at this. Slow down. The value of this of P is anything that's less than 2. So 2 is the most it could be. So it's got to be this way. For this one, you have E is greater than -2. So are we going to include 2? -2, I mean? No. So we put a circle there at -2. And it's anything that's more. E is more than 2, -2. So we highlight it this way. Okay. This is where it's going to get complicated. What's called a compound inequality. It's the result of combining 2 inequalities. So we have a problem that looks like this. X is greater than 3, or X could also be less than -1. So what you need to do is you need to, we'll do the first problem. M is greater than -2. M is less than -2, or M is greater than 1. Step number 1. You need to graph both of the different inequalities. So you know how to do this. You can graph this, and you would put a dot at -2. Would we do everything to the right or everything to the left? Careful. The value is anything that's less than -2. So am I going to the left or to the right? Going to the left. And then you got to graph the second inequality. And we go, well, M is greater than 1. So we're going to put a circle at 1. Everything to the right or to the left? Because the value of this, anything that's more than 1, to the right. Then we're going to take a number line and we're going to combine them together. and put it on a number line. Okay. I want both of them on one number line.
Why would you?
Wait, you'll see. Trust me. Wait. What? Okay. Now, we have another problem. This is where it's going to get complicated, and this is why you want to do it on two different graphs.
How did you know what I was going to ask? Because he's a teacher, he knows everything.
Because of this. This is why you want to do it on two different graphs. Because first of all, if you were to graph this inequality, what you would do is you would look at this part first. And you would make your little number line. There you go, -4, -3, -2, -1, 0, 1, 2, okay? And then you go, all right, -3. And it's less, so I'm gonna put a circle there, and the symbol says less than. So you're gonna do this. But watch. Does that actually cover? Does that mean, is that correct? It's not. Because it says that B, if you read it correctly, it says that the value of B is more than -3. The alligator always eats the one that's more, right? So why would the alligator here be eating things that's less than -3? It isn't. The alligator eats more than -3 because the alligator always eats more. Every single one that you guys have done so far have always had the letter on the left side. This actually reads B is greater than -3. Do you see that? Do you understand that? Do you see how that got flipped? Because it writes three things in a row, that's why it got flipped. I did it right. This is right. So this is, my number line is wrong. The alligator is actually going to eat everything this way. Okay? Does that make sense? Because you got this is where I'm telling you, you have to slow down and recognize what it says. So then on my next number line, I've got this. B is less than or equal to 0. So I'm going to have -1, -2, or I'm sorry, I went the wrong way. -1, 0, 1, 2, 3, and so on. So I'm going to put my dot at 0 because I'm including 0. And because my B is first now, I can just read it normally. B is less than or equal to 0. So I'm going to do everything this way. Now, here's where I answer your question, Gracie. Why would we combine them? Why would we do it on two separate graphs and then combine them? Well, if I was to do it all on one to begin with, -4, -3, -2, -1, 0, 1, 2, I would have a circle at -3, I would have a dot at 0, and I would have everything highlighted this way and everything highlighted that way. That would mean that would include everything. But it doesn't. It actually, when you have your inequalities that come at each other like this, all you do is highlight what's in between and not the arrow. Do you see that? I know it got a little complicated there. But if you were to do that and you were to have and graph this inequality and then graph this inequality over here, you would all of a sudden have the whole number line, and that means that B is everything, which isn't true. B is actually the only the things that are in between -3 and 0. And it actually doesn't even include -3.
You just use two different colors so you can tell them apart?
No.
That's seriously.
This is what I just said. -3 is less than B is the same as B is greater than -3. In order to help you out, always put your variable first. It's going to help you determine and figure out what way your arrow is going to go and what way you're going to highlight, okay? Put the letter first, because in this problem that I had now, I didn't have the letter first in this spot, and that can cause some confusion. So instead, I took this and I flipped it around and I made sure the letter was first so that I knew what way to highlight. Always do that. It will help you. Now, and here's another little hint. Never mind. I'm not even going to give it to you. I'll talk to you about it tomorrow. Oh, man. It has to do with the letter or the word or. Letter or. If you were to graph this one, you have a number line. Okay? Our lowest one, let's see, we got, I'm gonna start at 0, 1, 2, 3, 4, 5, 6, 7. All right. First of all, W is less than 2. So, should I put a dot or a circle of 2? Which one? Quick, 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 quick. Cesar. Circle, because we're not including 2. Now, what way do I highlight, left or right? Because W is anything that's less than 2. Left or right? Ooh, 50-50. Left, very good. Because anything that's less, okay? W is greater than or equal to 4. Dot or circle of 4. But you didn't do 2 graphs. You know why I didn't do? Usually if you see an or, you can just do it on one graph. If you don't see the or, chances are your problem is going to be one of these things where you're going to have in between. Okay? Now, what should I do first on this problem? Yeah, I would rewrite this to say G is less than 5 and G is greater than or equal to -3. Then I would make it on 2 graphs. Let's see, 5, G is. circle. G is less than 5. This way. Then I do another graph. Include -3. G is greater than -3. Then I make one big graph like this. And I start at -5, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay. I had a dot I had a circle at 5. I had a dot at -3. My circle at 5 went to the left. My dot at 3 went to the right. And I'd highlight in between. Okay? That's how I would do those problems. All right? I'm going to give you a worksheet. On your worksheet, you have 13 problems. Numbers 5 through 13, you have to make a number line type graph. Use the back of your paper to do it. Don't try and cram them all in on the front side, okay? Use the back as well. All right?